Technical Director at Amberg Engineering and Vice President of ISEG. He has also worked for L&T and Geodata in principal positions of design consultancy head before joining Amberg in 2018. He has an international reputation as a qualified tunneling expert with over 24 years of experience in design and construction in multidisciplinary international consultancy firms in 4 continents. He has developed the strength failure criteria, the CQD, which is also known as concrete quality designation, a new strain measuring technique based on digital image correlation, a new concrete damage plasticity model, and the GCD, which is also known as ground conductivity designation. The stress release hole technique in treatment of squeezing, swelling, or heaving ground, and the I system, which he will be giving the lecture on today. He is highly competent in design with conceptual, computational, and analytical abilities, who has been succeeded and has problem solving capabilities and project management in the construction or infrastructure. It is an honor to host you, Dr. Hoss, on our platform, and we thank you for your continuous support to the TAI. Over to you, Dr. Hoss.
Yeah. Pleasure. Thank you so much. Let me just share the screen.
Yes, Doctor.
My screen is visible?
Yes, it's visible.
Fire and smoke that for
Okay. Thank you, everyone, for your presence in this lecture. The material of this lecture, including the presentation as well as the papers, will be provided to TAIym, and then it can be shared to the people who were attending in this lecture or who interested in knowing more about the same. I-TM is the I-Systems tunneling method, an all-in-one design construction solution for tunneling in or under any ground or condition. A tunneling method which contains classification, characterization, design approach, and construction advices. Today's lectures include the tunnel design in a brief discussion about the design approach, I-System, I-TM, and design procedure. It also includes the excavation technique.
Hello. Sorry to disturb you, Dr. Hoss. Your mic has been mute. We are still not able to.
Am I audible now?
Yeah. Now you are audible, Dr. Hoss.
Okay. So I apologize for this, and I would like to thank you again for everyone who attending in this lecture. This lecture is about I-TM, I-Systems tunneling method, an all-in-one design construction solution for tunneling in or under any ground or condition. A tunneling method which includes classification, characterization, design approach, and construction advices. Today's lecture contains the tunnel design, including the design approach, I-System, I-TM, and design procedure. Today also I will compare the excavation techniques with the tunneling methods to highlight more the difference between these two that unfortunately interchangeably by mistake is used by the tunnelers. I will go into details for the tunnel excavation techniques as well as the tunneling methods also. Then I would enter to the discussion about the ITM. I would explain about the application of ITM, concept behind the ITM, features of ITM, advantages of ITM, and utilization of ITM. ITM will be compared with the existing tunneling methods, considering the concepts and the principles. I would explain very little about the iSystems software that can be used in ITM. Also, I would be having a brief explanation about the pull length advisor, vibration-induced damage assessment, a stress release hose system, and finally the disclaimer and references. Let's start our discussion. Tunnel design. This flowchart that you are seeing in the slide, it is a flowchart considered for a tunnel design procedure. It includes design approach, which itself includes empirical, analytical, seismic, and observational parts. I will explain briefly about all of them. Another most important part of the tunnel design flowchart is the classification and characterization system. That in this case, we will be using only iSystem. Then is the tunneling method, which we are focusing on ITM. And finally would be the design procedure, including the data collection, ground zoning, ground behavior, diagnosis of the ground hazards, determination of the support systems, structural dimensioning, and finally structural verification. Let's go a little bit more into the details. Design approach in tunnel design. It includes 4 steps. Empirical part, which is the design practicality that usually defined by the classification system. Analytical part, which is the design core, that in that part we are doing the structural dimensioning as well as the structural verification. Seismic part, which is the dynamic design part of the part for the design of the tunnel. That is very important also to consider the seismic effect in our structure. And finally, the observational part, which is the design adequacy. It is design as you go during the construction. In the tunnel design, the second part was the iSystem. What is iSystem? Today's lecture is about ITM, and ITM is the tunneling method of iSystem. But let me just briefly explain in one slide what is iSystem. Then if there was interest on that, in another webinar, I can present the iSystem comprehensively. iSystem has an engine including 5 numbers of indices and 2 impact factors. To be able to run this engine, we need to do the data collection first, DC, data collection, including the geohydrological data, geomechanical data, geometrical data, geophysical data, geostructural data, and geotechnical data. When all of this information obtained from the face of the tunnel, in this case, we are talking about iSystem for tunneling. iSystem is applicable for any underground spaces, semi-underground spaces, as well as the surface structures. But here, I'm focusing on underground parts. So when data collection is done, it would be entered to this system, and then these 5 indices, including the armature index, configuration index, hydro index, properties index, and a strength index will be calculated. As you see, each of indices having 20% share out of 100. The score is between 0 to 20. When it is calculated, two impact factors. One is the dynamic force impact, another one is the excavation technique impact. Will be impacting the total value gained from the summation of these 5 scores. And finally, I, which is the I system value, will be calculated, which is between 0 to 100. What is the output? Output of I system would be 2 important things. One is the I class, another one is the IGC. I class here is shown in this table, classifying the ground irrespective of soil or rock to 10 classes from I1 to I10. For example, 100 to 91 I1, 90 to 81 I2, and so on until 10 to 0 as I10. What is the output of I class? Output of I class is these 6 parameters here. SS, which is the support system. I class will tell you what support system you need for your tunnel. Another one is the excavation technique. It would tell you how to excavate the tunnel, which method or technique of excavation to be utilized, how much to be your pool length. Then IT, which is the instrumentation technique, it would be giving you advice how to monitor your underground space. Next one is the PT, which is the prevention technique. It would assist you how to prevent collapses and failures or incidents in your tunnel. Then FTE, which is the forecast technique. It would be giving you advices that how to predict the ground ahead of your face. We can't drive in the tunnel with lights switch off. We need to predict the ground and move ahead in the tunneling. And the last recommendation from the I class as output of I system is the design remarks. It would tell you that what should be your philosophy to design this tunnel. Another part of output of I system is the IGC. IGC is the I system's ground characterization. It also includes 6 outputs that is shown here. Modulus of deformation of ground, unconfined compressive strengths of ground, uniaxial tensile strengths of ground, Poisson's ratio of ground, internal friction angle of ground, and cohesion of ground. These parameters are also the output of I system as I system's ground characterization. With these parameters, you would be able to design the structure or review your design. Now, based on this I class and IGC that we obtained, as you remember, we collected the data, DC, then it included the geotechnical and geomechanical data. Then we entered in the I system engine and we calculated the I system. Output was I class and IGC. Based on these 12 parameters, you would be able to predict the ground behavior. As an additional feature to all of those parameters that's given to you as output of I system. Now, let's get back to ITM. ITM is the I system's tunneling method. In a simple word, ITM is the underground part of I system. So it is called ITM. It has assumptions, very important assumptions that mentioned here, and very important principles that I would explain it in the when I enter particularly to the ITM discussion. Finally, in the tunnel design, we enter to the design procedure. Design procedure includes 7 stages. Again, DC, which was the first step, which is already done because you were going to calculate the I system. DC is the data collection. It is the required data for I system and design. Next stage is the GZ, which is the ground zoning. If we have 3 kilometers, 10 kilometers, X kilometers of tunnel that we are going to design, we need to divide this entire length to some particular zones with similar properties and design the tunnel for that particular zones. For example, if finally we divided 12 kilometers tunnel to 6 zones, we need to give 6 designs. Means that each zone would be having its design. It is a function of ground properties. I system will assist you to do the GZ also. Then is the ground behavior. In the previous slide, I said that how it can be driven from I system. It is based on the mechanical responses between the ground and the structure you want to make. In this case, the structure is the tunnel. It can be underground station. It can be a semi-surface structure. Next stage is the ground hazard. Diagnosis of the ground hazards. Again, this part will be given to you by I system. It is based on the failure categorizations. I'm not going to go into the details of this. It is available in I system 2021 edition. The paper is available, and I will be providing it to the organizer, and they would be distributing to you. Next stage after ground hazard diagnosis is the support system determination. That again, it would be determined by I system. I system, as I explained here, it would be giving you which type of support system you need to go ahead. So support system would be defined and determined by I system. It is based on I system for each ground behavior and associated ground hazard. The next one is the structural dimensioning. It would be partially done by I system and partially by analytical methods to dimension the structure. It is the design analytical calculation. And finally, you need to verify your design, which is the SV, structural verification. Relative safety margin definition for each individual structural dimensioning that you have already done. Now let's go a little bit further into the tunneling. You may interchangeably use excavation technique as tunneling methods, and you see from experts also sometimes they are using it interchangeably, but it is not right. Tunnel excavation techniques are employed in tunneling methods as an important element. It's not the tunneling method. It is one important element of tunneling methods. So my request to all of you who are attending in this session is that please differentiate between tunnel excavation techniques and tunneling methods. The reason that I am emphasizing on this is that It would lead misunderstanding of tunneling, misunderstanding of ground behavior, and the result would be huge mistakes during the construction or before construction in the design and pre-design phases. So let's go into the details of tunnel excavation techniques. Then you yourself would get the differences. Techniques employed in tunneling methods for excavation purposes only. It is only and only for excavation. But different type of excavation methods can be utilized in different types of tunnelings, in tunneling methods. Number one of tunnel excavation techniques is manual or man. It is applicable for small to large scale excavations without use of explosives. Example is the partial sequential digging, partial sequential excavation. May I request microphone to be switched off? So for the manual techniques of excavations, partial sequential digging technique, partial sequential excavation technique, sequential excavation methods. It is an American method. Unfortunately, many people calling it as a tunneling method. It's not a tunneling method. It is only a sequential excavation method, usually used for full face excavations. It can be used, the manual excavation techniques, for heading and benching or for full face excavation. Another excavation technique is the mechanized excavation. We are calling it ME. ME is employed for medium to large scale excavations in tunneling without use of explosives. Continuous miner, excavators, hydraulic hammers or jackhammers or chisels, road headers, shearers, and TAIYMs are the machineries that we use in mechanized excavation technique. Many of you maybe heard TAIYM as a tunneling method. It's not a tunneling method. A tunnel which is excavated using TAIYM is a conventional tunneling method. TAIYM is used as a conventional tunneling method. However, we have other types of conventional tunneling method also. But in the case that your TAIYM is activating the stresses ahead of your faces, that would not be conventional. That would be a different type of tunneling method. So try to remove the confusion from your mind about the excavation techniques and tunneling methods. Another excavation technique used in tunneling methods is drill and blast. We call it D&B. It is employed for a small to large scale excavation with use of explosives. Several types of blastings are explained in the I-System 2021 edition that you can study in that paper. It includes residential blasting, commercial blasting, industrial blasting, infrastructural blasting, controlled blasting, mine blasting, production blasting, and uncontrolled blasting. So drill and blast is another excavation technique employed in tunneling methods. And the last excavation technique is called open cut or OC. I put this one here for tunneling because it can be employed for semi-underground or semi-surface structures, like stations in metro. From surface of ground, with or without explosives, depends if it is in the city or it is in the mountain. Area mining method, open pits are examples of OC. Now let's explain about the tunneling methods. Methods employed in design, construction, and maintenance of underground spaces. Three important words is used in the definition of tunneling method: design, construction, and maintenance. You may raise a question in your mind: why maintenance? Why design? Usually you have heard about tunneling methods for construction. But from now, you put this question in the mind, and I hope that you will get the answer at the end of this lecture. So, tunneling methods are the methods employed in design, construction, and maintenance of underground spaces, including the tunnels. Two types of categorizations I can present here for tunneling method. One, medium-based, another one, concept-based. Medium-based tunneling methods are based on the medium in which I would request microphone to be switched off, please. Medium-based tunneling methods are based on the medium in which the tunnels are constructed in. And concept-based is based on the concept that tunneling methods are developed for. It is very important. When you want to select a tunneling method, you need to consider this categorization. There is another classification for tunneling methods based on medium, which is the first category, medium-based. We are calling it rock tunneling, soil tunneling, and underwater tunneling. So medium-based is the rock tunneling, soil tunneling, and underwater tunneling. It doesn't mean that you have a tunneling method, it is called rock tunneling method, or it is a soil tunneling method, or it is an underwater tunneling method. No, any of existing tunneling methods can be employed if they are capable to be used in design, in construction, and in maintenance phase for your tunnel, can be used for rock tunneling, for soil tunneling, or for underwater tunneling. But you need to check the tunneling method you are choosing against these three criteria. Now let's see what is concept-based tunneling methods. Two simple concepts, very simple concept: civil tunneling and mining tunneling. Why I have separated the civil tunnelings from mining tunnelings? In civil engineering, our mindset is for a permanent structure. Usually we are thinking of over 100, or in some countries we are considering 125, or in some clients defining over 200 years. That structure should be maintained. That structure should be healthy during that period of time. And that period of time is usually over 100. We call it permanent structure, permanently constructed. For civil tunneling, you can use I-TM, you can use conventional systems, you can use cut and cover, you can use NATM, NMT, pipe or box jacking, or SCL. SCL is the sprayed concrete liner. What is the mining tunnelings? Mining tunnelings are based on temporary concept of life. In mining, we are not thinking that we are going to make the tunnel to stand forever. No, we are going to make a temporary tunnel. And mainly, we are thinking about the margin of benefits that we are gaining. Why? In mining, we are going to extract the ore from the ground. We are not going to make the tunnel for civil purpose. We are making the tunnel to have access to the ore. So they are temporarily constructed, including underground mining methods. You can use I-TM also for this purpose. So now you know the difference between the tunneling methods. Maybe you knew that before, but I tried here to clarify what is the difference between the tunneling method and excavation technique. Now is the time to go a little bit further into the detail of I-TM. For your information, if you have more interest on I-TM, there is a paper published which is available also. I can provide it to the organizer. It is about I-TM, and you can go into details of I-TM here. I would be trying to give the most important information of I-TM in this lecture. Let's see what is the application of I-TM. It is designed to be applicable in any medium, means that rock, soil, underwater. And it is designed to be applicable under any condition. Any condition, I mean about the special condition of ground. Viscoelastoplastic ground, time-dependent behavior, fully plastic ground, rock burst, ground burst, coal burst, in any hazardous condition. So this is I-TM. And it can be used in pre-design phase, to design phase, to construction phase, to post-construction phase, maintenance. So it is considering all of these three aspects: design, construction, maintenance. What is the I-TM concept based on? It has some assumptions here that I would explain one by one. In I-TM, arch pressure effects at any depth of placement of the tunnel will be considered importantly. And we are not neglecting the depth. We are not neglecting the arch effects. So you are not required when you are using I-TM to classify the tunnel based on depth to shallow and deep. You are not required anymore to do this classification. Based on any depth, arch pressure is considered. Another assumption or another concept is that it is comprehensively applicable in any medium, in any condition, under any condition. Next concept is that it would allow the structure of tunnel to release the stresses to release the deformation in a controlled manner in plastic condition. It gives you flexibility of contract to ease the management of construction. I have worked in 4 continents, and I have observed how challenges are involved in the tunneling methods. Unfortunately, you will see in any of the existing methods that when you are using, sometimes your hand as designer is tied because it is not included in the EOQ, in the contract. And clients objecting you as the designer, please don't give this. I don't have this item. And I should issue non-schedule item for that. Please don't advise this. I'm not going to issue non-schedule item. You will hear this from the clients. ITM is resolving this, giving you a comprehensive range in the contract, that flexibility of contract would be given to the clients. So you, as the geologist, as the engineer, as the tunneler, as the designer of tunnel, would not be facing with such issues. Another important concept in ITM is life expectancy of the structure. It is based on permanent life expectancy for the tunnel structure. ITM is developed to save in cost and time as well. You are not required anymore to neglect the primary measures in your design for final measures. It means that primary measures are part of final measures in ITM. And the last concept is the utilization of surrounding ground's load-bearing capacity. It is utilizing the load-bearing capacity of ground, because ground is better than any structure you put manually to take the load. It means that it is giving you the active and activation concept of stresses in the surrounding ground. It is going to tell you that design the structure in a way that ground itself to cooperate in load bearing. Give a measure to improve the load bearing capacity of ground. Don't design passive structures. What is the features of ITM? I have listed it and demonstrated in the right-hand side. Use of I-system in design procedure. It is, when you are using ITM, it has embedded classification in it. Very simple. It would be assisting you in derivation of I-class, which is the I-systems classification. Derivation of IGC, which is I-systems ground characterization, giving you the most important mechanical properties of ground for analytical calculations. It is helping you to determine the ground zoning in your design, identifying the ground behavior for you, diagnosing the ground hazard associated with each ground behavior. It is determining the support system for you. It is assisting in structural dimensioning, and it is helping you in structural verification. Another feature of ITM is that employment of I-system in construction for pre-excavation evaluation an application of I-class and IGC. Another feature is that employment of post-excavation damage assessment tools. None of the tunneling methods, existing tunneling methods, giving you this feature. Any type of excavation you do and you employ in your tunneling method, any type, even mechanized, even manual, you are disturbing the ground and you are further deteriorating the ground. You are downgrading the quality of the ground compared to the time it was virgin. That's why virgin stresses converted to the induced stresses after excavation. ITM gives you the opportunity to assess the damages you are applying to the underground structure during the excavation. It is called vibration-induced damage. The related paper is also available. Another feature of ITM is implementation of active pre or post-excavation support system, provision of suitable excavation techniques, use of efficient instrumentation techniques, application of intelligent prevention technique against any failure or collapses or surprising incidents, exploitation of high performance forecasting techniques, to have light, to know what is going on ahead of your faces in your tunnels. What is the advantages of ITM? When I was explaining about the application, about the concept, and about the features of ITM, most probably you have got the advantages. I would like here to summarize it about the advantages. Applicability in any media, rock, soil, underwater. Feasibility and practicality under any ground condition, covering varieties of ground behavior and hazards, safety and optimality in design and construction, cost efficiency, consideration of the primary measures as part of final measures, uniformity in utilization, embedded classification and characterization system of I-system, I-class, IGC, provision for pre-excavation evaluation, embedded I-system and GCD. GCD is ground conductivity designation. Recommendation on active support system as output of I-system, including pre-excavation measures, including systematic horn bolting, crown periphery spiling, four-poling, pipe roofing, pre-excavation grouting, pre-excavation injection, face bolting, and etc., including post-excavation measures containing systematic radial boltings, rigid ribs, LGs, lattice girders, fiber reinforced shotcrete, drainage holes, stress release holes, ring closures, and etc. Suitable excavation technique ET, including manual PSD or PSE, partial sequential digging, partial sequential excavation, mechanized excavation, drill and blast, pool length calculation, efficient instrumentation technique, IT, including 3D monitoring, digital image correlation, or other techniques which is proposed by I-system. Intelligent prevention technique, PT, example is the techniques to prevent the hazards. High performance forecasting techniques, including electrical resistivity tomography, ERT, MASW, or multi-channel analysis of surface waves, SRT, which is the seismic refraction tomography, and TSP, which is the tunnel seismic prediction, provision for post-excavation damage assessment VID, and provision for flexible contract, hassle-free managing of time, cost, and resources. How to utilize it? How to utilize ITM? I tried to explain it in this slide for design phase as well as the construction phase. In the design phase, you will be doing the data collection, putting in the I system, making the ground zoning, deriving the ground behavior, identifying the ground hazards, determining the SS, and helping in ST. All of these stages from DC to ST is by I system, and then helping you in a structural verification. This is the use of ITM in design phase. And now, how to use it in construction phase. I know this question was in your mind, that how to use it. Now we have designed the tunnel. How to go ahead? Simple. You just calculate the I system for the fresh phase. Even the portal, now you want to start the tunnel. You just calculate the I system. It will give you the I class and the IGC. Based on the I class, recommendation given to you for the support system, for the excavation technique, for the instrumentation technique, for prevention of the failure, for the forecasting, advance, start the excavation. Advance, add your tunnel, right? And based on the IGC, review your design. Means that you, for example, advance at the tunnel for 3 meters. Now you reevaluate it. You reevaluate your ground condition. Again, using I system. Now, as you have done the blasting, or you have employed any excavation method, you also calculate the VID. Assess how much damage you have applied. Check your observations, and finally, do your judgment. Repeat this procedure. Advance, apply I system. Apply I system and go ahead. Apply I system and go ahead until your tunnel is broken through. What is the difference between ITM and existing methods? I have listed here the most known tunneling methods here together with ITM. Then you can judge based on concept, application, and employment. Application in phases, in media, under conditions, under special conditions. For pre-design, design, construction, post-construction, and for the media in rock and soil, or underwater also you can add. The tunneling methods that I have listed here is the conventional tunneling method as the oldest tunneling method. Cut and cover, and ATM, Neo-Austrian tunneling method, NMT, Norwegian method of tunneling, pipe or box jacking, sprayed concrete liner, and ITM. In the pre-design, application in the phases, you see that it is not considered in the development of all of the tunneling methods except ITM. For the design phase, however, for the construction, all of them are considered for the design phase only. For the post-construction, none of them considered, but ITM is considering. In media, of course, conventional, of course, cut and cover, of course, NATM are applicable, but NMT conditionally for particular types of rocks applicable. Pipe or box jacking is not applicable in rock. SCL is conditionally applicable, and ITM is fully applicable. For the soil, conventional is applicable. For cut and cover is applicable, but NATM and NMT are not applicable. Pipe jacking is applicable, but SCL is not applicable, and ITM is fully applicable. Under a special condition, none of them considering the special condition, including the viscoelastoplastic ground, rock burst, plastic ground, fully plastic ground, time-dependent ground, coal burst, or whatever. ITM is applicable. For the employing, permanent life expectancy for tunnel structure, almost you can't find it. This concept in the developments of none of them. The same for flexibility of the contract, you can't find it. For the surrounding grounds load bearing capacity consideration, an ATM and NMT as well as SCL is considering. However, ITM is fully considering. Arch pressure effect, NATM conditionally applicable, and the pipe or box jacking is applicable. SCL conditionally applicable. ITM is fully applicable. Controlled release of deformation in plastic ground, NATM conditionally applicable. ITM is applicable, others not applicable. Primary measures as part of final measures, only NMT and ITM applicable. The rest of them not applicable. So you see, based on the concept, these tunneling methods are developed, most of them are lagging behind and they are not comprehensive enough. What about the principles? The principles I have considered for the comparison is the recommendation in construction procedure, including support system, excavation techniques, instrumentation technique, prevention technique, forecast technique, and stages in construction. Almost none of them included these principal parts for that, except in some special parts, for example, in NATM, partly included for instrumentation technique, or for the NMT, only included for the forecast technique. But the rest, you see that very rarely that they are proposing support measures, they are not proposing, they are not giving you the excavation technique, they are not recommending comprehensively what is the instrumentation technique, prevention technique, or others. However, ITM providing you all of these concepts, all of these principles. For the embedded classification, except NMT and ITM, none of them having the embedded classification. For the embedded characterization, none of them giving you characterizations for the ground, means that none of them giving you the mechanical properties of ground. ITM will give you. And for the post-excavation damage assessment, none of them giving you this assessment. ITM is giving you. Let's see how we can ease the use of ITM. It's simple. A UK company, as well as in a joint venture with a Norwegian company, developed the iSystem software. I should clarify here. iSystem is developed by myself, but the iSystem software is developed by a Norwegian UK company. And this software is quite simple software. In 4 minutes, you can enter all of your input data and you will get valuable outputs. The use of iSystem software is shown in this flowchart, easy. Select the type of structure, including the underground for tunneling or underground spaces, caverns, whatever, stations, whatever. Semi-surface structures or surface structures. Enter the input data. Compute the iSystem. It would give you the I-class and IGC. Beside I-class and IGC that listed here, it would give you all of these outputs. It would give you the I-class, which is giving you the support system, excavation technique, instrumentation technique, prevention technique, forecast technique, and design remarks. It will give you the IGC, which is the mechanical properties of ground for design and reviewing of the design. used in an analytical method. I-TM, which is the I-systems tunneling method. It will give you the GCD calculator. In a very simple calculator in this software, you can calculate the ground conductivity designation. There is another calculator, it is called PL Advisor. It is a small calculator that if you are using the blasting excavation technique in your I-TM, then you can calculate how much to be your safe pull length. That's considering everything, including the stand-up time and everything. Peak particle velocity predictor, it is a problem for all of the engineers, especially in India. I see that peak particle velocity is neglected, and tunneling is going on in most of the projects I have seen without measuring peak particle velocity. In this software, in a very simple calculated, it will give you the peak particle velocity value, and you can know what are you doing with your blasting, how much damages you are applying. If you are driving in SSH ground, which is squeezing, swelling, and heaving condition, there is one identifier calculator in this software which is giving you the chance to identify the ground if it is squeezing, swelling, and heaving ground or not. And based on that, you can get the advice from the I-system output. It also give you systematic bolting calculator, means that you can calculate and configure your systematic bolting in the I-system. And finally, vibration-induced damage assessor, also another calculator that's giving you 5 methods of assessment of the damage you are applying during the excavation in your I-TM tunneling method. I have provided this example here as PL Advisor, which is developed in 21. How that PL Advisor in I-system software is based on, which is giving you a very quick calculation for your safe pull length if you are driving with drill and blast. This is another example of vibration-induced damage assessment, which is the damage indicator that you can use the I-system again here or PPV to classify your damage from unscathed, unnoticeable, negligible, minor, mild, moderate, major, destructive, or catastrophic. And so you will get the notice and you will issue it to the contractor to be careful and not to damage the ground, not to deteriorate the surrounding ground. This is SRH system. The papers, related papers, also available. The same concept is used in the I-system software as the identifier and the criterion that can identify the SSH ground from non-SSH ground. And also it would give you the solution if your ground is SSH, means that squeezing, swelling, or heaving, how to treat it. And this SRH system is going to replace all of the conventional methods used for treating the squeezing grounds, swelling grounds, and heaving grounds, including the Toss enhancement, TH profiles, yield profiles, yield shotcretes, and huge costs involved with those conventional methods. This SRH system, if you are interested, you can study about that one. However, it is out of the scope of this lecture. The references is provided here for your further study about whatever I explained here. I would like to answer your questions if you have any question on I-TM. I know one big question in your mind is about the I-system and what is that, how it works, how it can be calculated. It can be presented in another lecture this time, and this lecture would not allow me to present the I-system. So if you have any question, please don't hesitate to ask.
Thank you, Dr. Hoss, for such a good webinar. Now we'll Anyone has questions regarding this webinar?
Hello.
Yes.
Yes.
Yeah, Dr. Ross. Thank you for the presentation. It looks like a lot of information goes into this, and we are trying to simplify the tunneling method, as you said, along different phases of a project. Just this as a out of interest, is this amalgamation of a lot of theories and formulations available uh, put into a systematic form? Is this what this is about?
Very good question. ITM is developed, or better to say, because ITM is the underground part of the I system. I would focus on I system in responding to your question, in answering your question. I system is developed to ease all of the challenges in design, derivation of the mechanical properties, and use during the construction. So difficulties, challenges, and complications all are eased. All of the difficulties, all of the challenges, complications, and confusions involved with classification methods, characterization techniques, or formulas are eased in iSystem. So that's why I invited all of you to just go through the iSystem paper, which is the edition 2021 edition, the latest edition, to have a look at how easy it is and how easy is the use of the iSystem software. There is concepts, formulations, experience behind of each of indices and impact factors used in iSystem to give you the I value at last. But for a user, as designer, or as an tunnel engineer, or as a geologist, all of these things are eased in use. Means that in a simple statement, you can daily use it without complication, without confusion, and without requirements of going through a lot of theories, a lot of calculations, a lot of confusions. You can do that easily in your daily basis, design as you go, construction or post-construction phases, even in the pre-construction phases. It is already in use in USBR project in Tunnel T14. The Tunnel T14 is designed based on iSystem and ITM. I have not forced up to some stages the people who are working in Tunnel T14 to use the ITM. I left it as their choice to select which method they want to go ahead. But when themselves faced with the difficulties in movement using NHT, they themselves switched to the ITM. And after that, now ITM is in practice. Tunnel T1 is the most challenging tunnel in India by far from any ground condition you have heard about. It is the most challenging tunnel in India. It is designed, and if you are aware of that, it is since 28 August 2016, this tunnel faced with difficulties in advancement, and they could not be able to move a centimeter in this tunnel for 2016 till now, till March 2022. In March 22, it is designed based on iSystem and ITM. Tunnel is now moving, and a regular advancement is obtained at both phases. and 336-meter balance of tunnel. Since 2016 was balanced, now it has reached to less than 290 meters. And so it means that it's easy to use. It has a powerful concept behind. It has a powerful experience and formulations, theories, and empirical methods behind, but it's not going to confuse you in use and challenge you in use. So geologists, engineers, and designers is using it and without difficulties. I hope I addressed your question.
Yeah. Thank you, Dr. Ross. Actually, I was not so much worried about the confusions, but sometimes, like other classification systems, we've seen that when things are oversimplified and we use something as a black box, it becomes very dangerous without understanding the concepts.
Exactly.
So I'll take your recommendation and go through the paper to understand better. Thank you for this session.
My pleasure.
Good afternoon, Dr. Ghosh.
Good afternoon.
Yeah, when it comes to the previous methods we used to, devise methods like Q-value system or the RMR-based system, experienced geologists or geotechnical engineers would go to the face, analyze it, and we could easily predict, what the RMR is, what the Q value would be, which rock class it will lay in, and will accordingly decide based on the factors that we have, based on the designs we have. But when it comes to the new system you are proposing, we'll have to take use of a software. We'll have to go back working on a system, put in the values, find out where it lies, what are the proposed. Doesn't it make it a bit cumbersome, a bit more, sophisticated, but at the same time bit more cumbersome method when it compared to the previous systems, the Q value, the RMR? Doesn't it make it, now we have to use a software? Okay, it would take 4 minutes. I agree. That's a very good thing. But it would take us 4 minutes on a software. But at the same time, if we have experienced geologists, experienced geotechnical engineers, it wouldn't take them even that much time, when they are on site, when they see the rock conditions, they can decide, yeah, plus minus, there would be some, corrections to be made. But wouldn't isn't this system a bit cumbersome compared to the previous ones?
Sure. A very good question. And I'm happy that this question is raised. The answer to this question is easy. No, you are not required to use the software. You are not required. The software is developed to ease the use. We are in the information technology century. Everything in our hands, from the applications in our phones or on our laptops, going to ease our life. The iSystem software is developed to ease your life as a tunneler, as a geologist, or as a designer. It is not going to force you that iSystem can be calculated only if you use the software. No, not at all. Not at all. iSystem is developed as a method of classification and characterization system. And when you take the paper, you can calculate it on your paper. It may take on the software 4 minutes for all-in-one. On the paper, it may take 10 minutes to derive the scores as you are deriving the score, for example, in RMR, in RMI, in Q, in other systems, in RMRB, in BRMR, in whatever methods. You need to derive the parameters, you need to derive the score, sum the score, and it would give you a class, right? iSystem the same. But iSystem is based on more comprehensive concept. It is considering both soil and rock. It is considering all condition, all special condition, but it is not required you to use the I-System software. You can use it on the paper as you use other systems, right? The same also when you calculated the, that's why I recommended everyone after this to download that paper or receive it from the organizer to go through to see that what is I-System, how to use it. It's very easy. It's just tables provided for each indices that I mentioned as 5 indices and 2 impact factors. Each one has one table. From that table, you derive your score or your parameter, put as the indices, as the impact factor, and I is calculated. Simple. When I calculated, you would go to the table. If you are doing the tunneling, table of tunneling. If you are doing the slope stabilization, you go to table of slope. And you derive your class, you derive the measures I-System is recommending you as the support system, as instrumentation technique, as excavation technique, as forecast, as prevention, as design remark. Also, it is giving you 6 equations. You can put the parameters in the equation and you calculate your modulus of deformation, the Poisson's ratio, compressive strength, tensile strength, cohesion, internal friction angle, and use it in your design. So no, I would like to thank you for asking this question because it could create the confusion in the mind of the people who are attending in this meeting that I-System is classification and characterization can be done only by software. No, not at all. I-System software is just easing this procedure for you. In 3-4 minutes, you will get 4-page reports. That these 4-page reports telling you how to move in the tunnel and how to reevaluate your design and what is the assessment of the work you are doing. The same can be done on the paper and pen. I'm in love with pen. I'm always using that one. And for your information, I'm not Windows user. The software is developed for Windows, and I don't have that software on my Mac. So myself, I'm using on the paper. If you are interested, you can use the software or the paper.
I remember you once, thank you for your answer. I remember you once saying that an app would also be launched for the same purpose, if I'm not mistaken.
Correct. One thing I just want to tell you, this software is a commercial software, but the UK company agreed to give the full licensed software for educational purpose as free of charge, right? So that would be available for everyone, all geologists and tunnelers, designers, to use it free of charge. So there is nothing to be worried about the price. But the companies who is going to use it as a commercial software, they need to pay to that company who has developed the software. That's out of my scope.
Thank you for your.
Any more questions? I think Dr. Haas, if there is some questions, I will ask all the members to post us to us. We'll get back to you through Dr. Haas. Thank you, Dr. Haas, for your valuable time. We are very happy to hear from you, and we are eagerly waiting to see you again in YTC in very short time. So thanks a lot. Thanks a lot to all the members and the participants for today's webinar, for giving your time for this webinar. Just to remind you all that we are going to conduct YTC very soon in this month. The exact date we will confirm you on Monday. There might be some changes because of some venue issue, so that will be updated via mail. Lastly, to all the members, to Dr. Haas, TAIym this time decided, after seeing this great change in our climate. Tomorrow is World Environment Day. So TAIym request everybody to plant trees tomorrow to take care of the environment. And we have decided to share all the activities performed by our young members tomorrow on the eve of on this World Environment Day. You can share your pictures. We'll happy to share with all the young members that TAIym is uh, focusing towards focusing towards the protecting the environment also. So we'll like to have your pictures of planting trees and taking care of our environment. Thank you, Dr. Hoss. Once again, thanks to all.
My pleasure, Mr. Ayush Raj. I will be sharing the material of the lecture with you, so you would be able to share it with anyone who wants to have the presentation, as well as the papers.
Definitely, sir.
Pleasure. Thank you all for your attendance.
Thank
Bye.
you.
Thank you.